Okay, in this video I'm going to run through some of these exponential word problems, and just keeping in mind that there's really two basic equations that we're thinking of when we do this, where the a's are the same, that's the initial value, and also b is equal to e to the k. That's how those two equations are connected. And then also just a reminder that the relationship between b, which is the growth factor, and the growth rate, which are two different things, but they're connected by b is equal to 1 plus the growth rate. And if it's a decay rate, then it'd be 1 minus decay rate. Okay. So number one says, how long does it take for an investment of $1,000 to double its value if the interest is 12% compounded continuously? So first of all, the key word there is continuously. That's what tells me I need to use the E, the formula involving E. This is for continuous growth rate or continuous compounding. And so I'm going to start with y equals a times e to the kt. And so first of all, I'm going to write the equation, and then I'm going to use that equation to solve the problem. So in this equation, a is supposed to be a number, e is a number, k is supposed to be a number, t is your independent variable, and y is your dependent variable. So if I was to write an equation to meet this situation, the initial investment is $1,000, so that would be y equals 1,000. That takes the place of a. E, of course, is just e. Now the k, it says the value of the interest is 12% compounded continuously. So that 12% is the k if we write it in decimal form, because 12% is a decimal is 0.12, right? So we just put a 0.12 and then we put a t in there. So now we have an equation that represents this situation where t is the independent variable measured by years and y is the dependent variable measured in dollars, because that's the amount of money I have in the account. Just a little note that the a, whatever a is, y is going to be the same thing, only a future form of it. Same thing in both of these. The a is the initial value, the y is the some future value, but it's measuring the same thing. Okay. Okay, so then to answer the question, they said, how long does it take to double? Well, since we start out with 1,000, doubling it would mean I'd have 2,000. So what I'm going to do is put 2,000 in the place of y, and then I just have to solve this equation. So I first divide by 1,000, I get 2 is equal to e to the 0.12t. And then to solve this, you take the natural log of both sides. So that'd be natural log of 2 is equal to 0.12t, because natural log of e to the cancels the natural log and the e cancel each other out. And then I would just divide both sides by 0.12, so I'd have the natural log of 2 divided by 0.12 is equal to t. I go to my calculator, and calculator. Natural log of, natural log of 2 divided by 0.12. So that would be 5.78 approximately. Remember, t is measured in years, so that would be almost 6 years. Okay, so here in number 2, he says you place $950 in the bank at 3% interest, compounded daily. So notice this is compounded daily, not continuously. See the difference? So since it's daily, I'm not going to use this one anymore. I'm going to use this one, because it's not a continuous growth rate. So I'm going to start out with y equals a times b to the x or t or whatever. And we know that 950, that'd be the initial. So that would be y equals $950. And my b, okay, this is where the thing I said earlier, where this comes in. So we know that b is actually equal to 1 plus whatever the growth rate is, right? So this is going to be, better erase that. This is going to be 1 plus something, right? Now 3% interest, when in a a bank account, when they quote you 3% interest, that refers to the annual rate, the annual interest rate. They're not giving you 3% a day. So we have to adjust that to the daily rate. So the way we do that is we take the 0.03 and we divide it by 365 because there's 365 days in a year. And then because, again, it's a daily rate, we're compounding daily, the t up here is going to be measured in days. T measured in days. Okay? So now when it says how much money will you have 5 years from now, well, we just take y is what I want to know. 950 is that. 1 plus 0.03 divided by 365. And in t, I'm going to put not 5, because remember, t is measured in days. So that'd be 5 times 365. And I get 1,825. So now I just got to calculate this. So I would go 1 plus 0.03 divided by 365. Raise that to a power of 1,825. And then multiply that by 950. So I got $1,103.73. So 5 years from now, I would have $1,103.73. So that's nice. The bank gave me about, what, 150, 100 and some dollars. That's pretty nice. Okay. Here's another compounded continuously. So similar, you'd say invest 2,000. How long it take to get to 3,000? So that means I'm going to start at 2,000. And I'm going to take e to the 0.15 t. And we want to know how long it takes to get to 3,000. So I would put the 3,000 over here. And we'd solve it. 2,000 divided by 3,000 is 1.5. I mean, 3,000 divided by 2,000 is 1.5. E to the 0.15 t. Take the natural log of both sides. We get natural log of 1.5 is equal to 0.15 t. And therefore, t is equal to the natural log of 1.5 divided by 0.15, I mean. And so that would be natural log of 1.5 divided by 0.15. 2.7. Try to make that approximate. How long it take to get to 3,000? It'll take 2.7, and that would be years, right? Okay. Here's similar. So if you have 10,000, you need to double it in 10 years. What interest rate would you need? Now, this didn't say whether it's compounded continuously or not. So you could say, well, I'm going to think continuously. Continuously, since I didn't say. So that means I'm going to start with 10,000. E to the kt is equal to y. Now the k is I'm trying to find in this case. So I'm going to fill in the other things I know. So this would be 10,000 E, and the years would be 10, so that would be 10k. And I want it to double, so that would be 20,000 over here. So I divide both sides by 10,000. I get e to the 10k is equal to 2. And then I take the natural log of both sides. Natural log of e to the 10k would be just 10k, because the natural log and e cancel each other out. I'd have a natural log 2 over here. So that means that k is equal to the natural log of 2 divided by 10, which would be, see, natural log of 2 divided by 10. 0.0693. which would be 6.93%, right? Now, if let's say it's instead of compounded continuously, let's say it's compounded annually. That means once a year. So then we'd say 10,000 times b to the 10th power is equal to 20,000. Okay, so I'm using the other formula instead of the e formula. So I divide by 1,000 again, and I get b to the 10th is equal to 2. Now in this case, I don't use logarithms because I have a base, the variables in the base, so I take the 10th root. So b is equal to 2 to the 1/10th power. That's how we do 10th roots. So let's see, that would be 2 raised to the 1 divided by 10. And I get b is equal to 1.072-ish, approximately. So now remember though, if we're looking for interest rate, that's not what b is. B is the growth factor, the thing I multiply by over and over again to get it to grow. So, and we again go back and remind ourselves to this little thing. B is equal to 1 plus r. So I have b right now, I want r. So that means I just need to subtract that 1. So right here, so that means that r would be 0.072, or otherwise known as 7.2%. Now the answers are different. Well, of course they're different because here is compounded continuously, there is compounded annually. So we would expect them to be different. Because when you're compounded continuously, you're getting money on your interest more often. So it actually grows a lot faster, as you can tell. Okay. Here's another one. You can place 3,300 in the bank at 8% interest compounded quarterly for 5 years. So that would be 3,300. Once again, we're going to have to divide that 8% by the number of times of compounding. So since I'm compounding quarterly, that means 4 times a year. We'd take that 0.08 and divide by 4. And also, this would be measures in quarters. So in 5 years, you'd have 20 quarters because there's 4 quarters a year. And we'd use that to calculate. So that's going to be 0.08 divided by 4 is 0.02. So 1.02 raised to the 20th power. And then multiply that by 3,300. And we get $4,903.62. Okay, let's see. Let's do one of these Half-Life ones. I think that's helpful. There's some on the XYZ homework like that too. So the half-life of radon 22 is 4 hours. If you have 20 grams of it, how much will be left 2 days from now? So half-life means that that's how many hours it takes for you to lose half your stuff. So if you start out with 20 grams, in 4 hours you'll have 10 grams. But then in another 4 hours, you'll have 5 grams. So in other words, the decay rate kind of slows down. So you're losing half your stuff every 4 hours. So every 4 hours, whatever you had is being cut in half. Okay? So one way to handle this is you could say I start out with 20 grams and I'm cutting it in half every 4 hours. So what I put up here is I put the number of hours divided by 4 because I would count how many 4 hours go into it. And so then it says if you have 20 grams of it, how much will be left 2 days from now? So then I would put 20 times 1/2, and I put, in 2 days, there's going to be 24 hours, so I'd put the 24 in there. And so we'd have 20 times 1/2 to the, 6? So there's 6 4-hour periods in it. Whoops, I said 2 days, didn't I? My bad. That should have been 48. There's 48 hours in 2 days. So that would have been 8. So So then we go 1/2 raised to the 8th power, and then we multiply that by 20, and we get 0.078. So there's not much left. There's been a lot of halving going on there. It's actually exactly 0.078125. So in 48 hours, there'd be 8 halvings going on. So if you can actually kind of picture that. So 20, half of 20 would be 10, half of 10 would be 5, half of 5 would be 2.5, half of 5 would be 1.25, half of that would be what? 50 plus 12.5, so that'd be 62.5 or 6.25. Half of that would be 3 point, oh, what am I doing? That'd be 0.65, sorry. 0.625. Half of that would be 0.3125. And you can see we just kind of keep going down towards that. Okay? That was 1, 2, 3, 4, 5, 6. There's 2 more of those and we get to that. Okay, so that's a Half-Life one. Here's another Half-Life one. We'll do that, and I think I'll stop there. Half-life of arsenic in the bloodstream is approximately 2 hours. If a person is poisoned with 2 ounces of arsenic in their food, how much arsenic will remain in the bloodstream 7 hours later? So once again, we're going to start with 2, multiply by 1/2, and every 2 hours it's going to drop another half, so I'm going to take 7 and divide it by 2. And that would be 1/2 raised to the 3.5 power times 2. So that would be approximately 0.177 grams left. Okay, I think I'll stop there, and please email me if you have some questions, or if you want to see one of these other ones in particular done, or something from homework too.